Hello students, in this video we're going to look at the graphs you're supposed to match. So make sure that you've already attempted to match these graphs and come up with a function, in fact two functions for each one before watching this video. Alright, so this first one is clearly a wave, so I'm probably going to need a sine function and a cosine function. It's got a few different transformations, so let's try to identify those features of the wave before we proceed. So the first transformation is obviously moved it up. So it looks like its top is 11 and its bottom looks like -1. So where's the center? An easy way to decide that if you're not sure about where the exact center is, this one's a little tricky, is you could say that, well, it's 11 and then it's -1, so total that's going to be +1. And then if we want this, that's going to mean that total we have a corridor width of 12, right? So then if we think about it, the amplitude is going to be half of that corridor width because the amplitude goes up and down. So it's actually going 6 up and down from something. That something, of course, was the bottom, so it's going to be -1 plus 6 to identify the middle of the corridor. So you, of course, don't need to think that difficult, but that's definitely a good way. That's the way to professionally know these kinds of waves. So the middle should actually be at 5, and I think if you look, I think it looks pretty close to 5 there. Yeah, so that's going to be at 5. Great. So now we know that this is supposed to be up by 5. All right. We know also that its amplitude we said was 6, right? So its amplitude is going to be 6. Let's see, what else? We need to think about sine or cosine, but before I do that, I need to identify the period. So it looks like if it starts at the beginning here, it's already done with a wave by the time I get to here, right? So that's going to be 1 up and down. So that looks like maybe 3/4. Tough call. So we might not be able to say exactly on this one. Let's see. Let's see where we can see 2 waves. So from there to there, and then it looks like it's going to start another one here and go to here. And then it's going to start another one here and go to here. So that's 1, 2, 3 waves. And then, so that's pretty close. Tough call exactly what that's going to be. So, looks like about 3/4. So this guy looks like about 3/4. I'm just going to take my best guess. That part's a little bit hard here. So I know that ultimately it's going to be 2 pi for a sine or cosine wave divided by the thing that transforms me. And it looks like I'm getting 3/4 pi when I do that here. So if I solve that little equation, I can get this. So it looks like if I cross multiply, I'll have 8 pi equals 3 pi times the b. So that means b would be 8 pi divided by 3 pi. So that looks like that's about 8/3. So that's a tough call, and I might not have this one exact. But that's what I'm going to say, is that the period is going to need an 8/3 in it. So the period, it looks like, was 3/4 pi. That's what I was saying anyway. So 3/4 pi. All right, so there we've got that. Now it looks like, for me at least, it was a little bit easier to see that this guy was going down first. So if it's going down first, that's suggesting a sine wave to me. So I'm going to say my first version of the function, call it f sub 1. It's going to be negative. The amplitude is 6. I'm going to say sine. I've decided I'm going to put an 8/3 in to get the right period. X, and then of course I need to establish that shift of +5. Now of course, why did I do this negative here? That'd be because it was going down first. There's one correct version of this function, or close. Now if you didn't have 8/3, like if you said this was at halfway, at half pi, then if you that would have changed this number inside a little bit, but you shouldn't be too worried about that on this particular one. Alright, you're supposed to come up with at least a sine and a cosine version, I think. So let me do my second version, is going to be cosine. So where could I do a cosine here? So let me go ahead and, well, let's just switch colors and do our cosine in green. Alright, so our cosine, where would the cosine be? I think you've got a couple options. So to me it looks like maybe this right here might be a good option. So to that spot right there, that'd be a nice plain cosine. So if I take this curve and shift it over to that green spot, I ought to be able to do a cosine. So that would be, looks like about half. So I'm going to say negative, oh, and I don't want the negative now because that's going to be a positive cosine, right? So like 6 cosine, we'll keep the period transformation the same, and then we need to have a shift inside of right by, it looks like about half pi to me. So I'm going to go half pi to the right, and then we'll have plus 5. So if I take this guy, if I take my original cosine and move it half pi to the right, I'll be able to get to there. So that would take this kind of cosine, you know, cosine that was right here, and move it over to there. So there's one option. Let me do another option. We could also have like, let me see if I can, am I running out of colors yet? Looks like I am. So maybe I'll do one in black. So another option for cosine, there's of course an infinite number of options, but another option would be I can move it left a little bit right here to this spot right here. Yeah. So I think that would be negative or positive. No, that'd be a positive cosine still. So that'd be like 6 cosine, and I'd have my 8/3 in there just like before, except this one would be moving to the left, so it'd be plus. And how far to the left does it look like I went? Looks like maybe one, these look like quarters, so I'm going to say a quarter pi to the left. That's what I had there for that one, plus 5. Of course, you could have like negative cosines, so you could have a fourth function here, maybe that did a negative 6 cosine. And that one might be like 8, you know, still the 8/3 has got to be in there for all of them. Might be like x minus, if I was shooting for like down here, yeah, maybe like minus pi over 4 that way. Doesn't look like that's perfectly a quarter, but you get my intention here, I think. Okay, so there's all kinds of different versions of these graphs, but there's some of the correct ones. Now, is my absolutely sure 8/3? I bet many of you didn't get 8/3. If it's not exactly 8/3, that's fine. That just depends on what you saw the period to be. This one is a little bit hard to see. All right, I'll see you with the next two in the final video for this lesson.